All right, folks, we are going to do number 12. The velocity versus time graph for an object moving along the x-axis should... Ow. Sorry, folks. Anyways, that's in this figure, 2.12. Plot the graph, and it's not... it's a little hard to kind of be precise, but I think the answer is going to match. Actually, I don't think I've checked the back of the even solution for this one, but that's all right. I don't really care. Plot the graph for the acceleration versus time graph according to this. And I am kind of a fan of these questions, but at the same time I'm not, because if you're just introducing motion to somebody who's very new at this, I don't personally, in my opinion, think it's a good idea to have them start graphing it right away. But whatever helps you guys. If you guys are a fan, which I hope you are, then, and if it helps you, then maybe it does make it worthwhile to ask these. I don't really know. But plot the graph of the acceleration versus time. All right, so I'm just going to look at this. You can see that the velocity doesn't change between 0 and 5 seconds. So between 5 seconds here, the acceleration here is going to be 0. And between here and here, you're going to have a constant slope of 5 and 15. That's 10 seconds interval in the course of 16. So that's 1.6 seconds. So that's going to be 1.6 meters per second square in between the interval of 5 and 10 seconds. And then from 15 seconds, and then from 15 to 20 seconds, it's going to go back down to 0. So it looks something like this. So from 0 to 5 seconds, it's the velocity. There's no change of velocity. It's always constant. And from here, it's going to have a constant slope at 1.6 meters per second. And you can determine that by taking this interval 5 and 15. Or I know it's not, or maybe it's like a little less than 5, but who gives a fuck? So just say it's 10 divided by 16 and just put 1.6, and there's your acceleration versus time. And I didn't need this piece here, so let me erase that. So let's do the other one, part B. Determine the average acceleration of the object in the time interval of 5 seconds and 15 seconds. Now it's asking for the average acceleration. We know that the acceleration is going to be 0 at this point. But if we're not given that information, between the moment of 5 seconds when the acceleration is 1.6 meters per second and 5 seconds with my brain is a little mixed up right now. So in 5 seconds here, you have the acceleration of negative 8 meters per second. So let's start there. And at 15 seconds, the acceleration is going to be at 8 meters per second. So let's start from the top. 8 meters per second minus and minus is going to turn into a plus 8 meters per second, because that's the change between this output over the course of 15 seconds minus 5 seconds, which is exactly what I had, which is 1.6 meters per second square. I think one of the recordings didn't record, so there might be a little screw about it. But the way I determine this is taking the 8 minus the negative 8, so that's 16 in this between this interval between the 5 and the 15. So 16 divided by 10 is 1.6 meters per second square, and that's between 5 seconds and 15. And from 0 seconds to 20 seconds, that's from 0 being at negative 8 meters per second and at 20 meters being 8 meters per second. So that's the same thing as taking the 16 as the difference between the outputs, but the only difference is that's 20 seconds interval. So that's 16 meters per second divided by the course of 20 seconds. That's 8 divided by 10. So that's so the acceleration is going to be 0.8 meters per second square. And that's the other answer. It's just really just half of whatever that is, because it's the same. It's taking a half extra. And that's all. All right.